So our last topic in this introductory chapters is on density, and we're going to talk more about matter in the next chapters in the course, but we're going to start off by talking about a physical property of matter called density. And you know about density already. You know which is, what floats in water, what sinks in water. That's what we're talking about is density, and often it's relative in that case of floating. If you were to ask somebody which is heavier, a pound of feathers or a pound of butter, they have the same mass, but their volume is different because their density is different. And so you know about density intuitively, and we're going to just take some time using density as an introduction, again with this problem solving strategies, because you can calculate the density of something. If you know the mass and the volume of something, you could calculate that physical property density. So density has units, and the units are derived by the mass and the volume. And we've already talked about how we have liquid volumes or cubic linear volumes. So this would be for liquid typically, and this would be for a solid. And back in our measurements, we talked about how 1 milliliter is equal to 1 centimeter cubed. Those are equivalent units. There was no conversion you needed to do with those. They are the same values. And so as we talk about this, this is density. This is the formula for density. The density equals mass over volume. Mass measured in grams and volume measured in either those milliliters or centimeters cubed. And that's how you get that unit for density, where it's grams per milliliter cubed or grams per centimeter cubed. And so rearranging this, if you say knew the density and the volume, then you could solve for the mass. And so this triangle here is on your formula pages. And it's really a kind of a cheater way of rearranging a formula. So the way you fill it in is that density equals mass over volume. And the way this works is that if I wanted to calculate density, that's density equaling mass over volume. If I wanted to say calculate volume, I could look at the relationship of the other two variables being mass over density. So the other formula would be volume equals mass over density. And similarly, if I wanted to solve for mass, I could take a look at the relationship between the other two, and it's multiplication between those. So the third kind of arrangement of this formula is that mass equals density times volume. And so yeah, it's a way of rearranging a simple formula into its different iterations so that you could calculate an unknown if you knew the other two things. Your textbook has a great resource on page 43. We're also going to talk about density in the first lab and use our measurement skills. And so all of our density questions are going to use these formulas. And so again, focusing on strategy for problem solving in this, we're going to make a list of what we know in the question. So I zone in on these numbers. Sometimes word problems are intimidating to people, so this is my strategy. We determine what we need to know, and so list all the variables and put a question mark beside what you need to know. Set up the equation, so write it out. You're going to sub in and solve. Show your steps, and then when you finally give your answer, correct for sig figs and for units, and then does it make sense? That's an important thing to kind of check. So as we go through this first example, I'll try and model that strategy here. So in this one, we want to figure out the main component in a cleaner. We know that we have a volume. I know that because of the units that are given, so the volume equals 35.8 milliliters. And I seem to have a mass here because I have a gram. So the variable is m, the number is 28.1, and the unit is grams. Don't be confused between variables and units. Oftentimes by the time you get to this course, that's not a problem, but you're going to say it once just to make sure that that makes sense. So from this, what we're looking for is the density. We're going to compare that to the density table in your textbook on page 43 to figure out what it is that is the main component of this commercial liquid cleaner, because the density will be closest. That's a physical property that doesn't change. So I've listed what I know. I've determined what I need to know. Now I'm going to set up the equation. So if I'm going to calculate density, density equals mass over volume. I got confused because I had volume listed first. That's why we do this. Mass over volume. Then I'm going to sub in what I know. So I don't sub in with units. You can. And then I'm going to use my calculator to do this and round to the 3 sig figs, because I can take a look over here. I've got 3 sig figs in all my values. And so my answer is going to have 3 sig figs. So that would be 2.68 when I round what I get on my calculator. I could then compare to the textbook, and I can look at that table to determine that this is aluminum. That seems weird. I'm gonna have to double check that one. All right, seems very strange, but let's just go on. I'm not sure what kind of cleaner has aluminum in it, but anyway, let's carry on. So the next one here, we have that same idea. It's a word problem. I'm gonna go through it with the same strategy. So this one is a density of that, so I know that that's my density. And those units are really helpful in figuring out which variable I have. The volume is this. And what I'm trying to do is figure out the mass. So the mass is what I don't know. I do know that the equation, then I could go back, the equation would be that mass equals density times volume. And you could put a dot in there or just smack up beside each other. I'm going to sub in what I know as 2.68 for that density and the 542 for the volume. By listing them over here, if you do have to change the units, it gives you a place to do that work so that when I sub them in, I don't sub them in with the units and I can make some sense of them that way. Okay, so doing the math on this one, I'm going to round it to 1450 grams. And this is where reading the question and kind of making sure that it makes sense. This has asked me to convert it to kilograms. And so I would say that I'm going to divide by 1,000. If I wanted to, I'll do this once. I don't think I did it in the notes or in my key. If I want to, I know that idea of dimensional analysis. 1 kilogram has 1,000 grams in it. And so that makes me divide by 1,000. Maybe you just knew to switch your decimal place, or maybe you're using the slidey chart. My final answer is 1.45 kilograms. Again, you can see the dimensional analysis. And I do that because maybe this is the time that dimensional analysis in the metric system is something that works for you. Okay, so the next one, a solvent has a density. So when I read a word problem, I just hunt for numbers and units specifically. We know that we want to find out the volume is occupied by 50 grams of the liquid. And again, the units tell me which variable. So the mass is 50 grams. I'm looking for the volume. So my equation for this one would be that volume equals mass over density. I know that from my triangle, and you can take a look back. If I sub in what I know, I've got 50 divided by the 1.31, and I've got a place where I can check my units over here, so everything's good. And I do the math correct to the 3 sig figs, I get an answer of 38.2 milliliters. All right, so the next one's here. We're going to use some information from our textbook and also kind of compare the two. So in this one, it says, which has the greater volume? This many grams of copper or this many grams of mercury? So in order to know this, I've got my mass, but I need to know my density. So I've looked my density up from my textbook. I know it's not in the question, but if I look at my textbook, copper has a density of 8.96 grams per centimeter cubed. Well, I have been given a mass here of 45 grams. I'm looking for volume. So volume is my question mark. I could do the same for the mercury. I could set this up knowing what I know. So my density I've pulled from my table in my textbook. I know that I have a mass of it of 65 grams, and grams are the units that I look for, and density is in the right units. In both of these cases, the equation that I would use is that volume equals mass over density. And so in this one, if I were to do the calculation, I'd have 45 over 8.96, and that gives me 5.0 mils, correcting to the 2 sig figs. And I'm going to compare that to what I get over here as the volume for the mercury. And so in this one, I take a look, I get my 65 divided by the 13.6 following the equation that I had specified and the information that I know. Use my calculator, correct to the 2 sig figs, and I get 4.8. So which has the greater volume? That would be the copper. This one has a greater volume. So the one down here, I'm going to list all the things that I know again. I've got the density of water being 1.00 grams per milliliter. I've got the volume being 19.4 milliliters. I was given that. And I want to know the mass. So mass is always going to equal density times volume. And I knew that from my formula. If I do this, that's just 1.000 times 19.4. And so correcting to the 3 sig figs, that's just 19.4 grams. I'm going to compare that to the gold now. So the density of gold from my chart is 19.32 grams per centimeter cubed, or milliliters, doesn't really matter. Typically gold is solid, so you'd put centimeters cubed, but it's absolutely interchangeable. It's not like you would be marked right or wrong. Either way, they are the same. And the volume is 1.00 milliliters. So if I multiply these two together, I'd get 19.3, correcting for sig figs. So which one has the greatest mass? That would be the water with the greatest mass. So in the lab, we're going to do these kinds of calculations. There is a way of finding the volume of something by how much water it displaces, and that's called Archimedes Principle. There used to be some examples in the notes here with it, but I've somehow have edited those ones out. So we're going to revisit that procedure in the lab. And so, like I say, there's not an example here, but it is in your textbook and it is in the lab. Archimedes Principle. It's like that idea that if you have a beaker of water, and you take the V1 of it, the first volume, and then you put the item in, well, that's going to displace as much water as is the volume of this thing that you put in it. And again, in this, I'm only mentioning it here, but it is in the lab. So that rounds out our math and our calculations intro to chemistry.